Another way to analyze your data is to find the deviation from the mean. Deviation from the mean, or mean deviation, is the mean, or average, of the distances of each value from the mean or average of the entire set of numbers. Yes, we mean mean twice. Find the mean, use it to work out distance, then find the mean of the distance. Mean deviation tells us how far, on average, all values are from the middle. Just think, distance from the mean. There are 3 steps to find the deviation from the mean. You should record these steps in your notes. You can pause the video now and press play when you're ready. Step 1. Find the mean of all values. Step 2. Find the distance of each value from that mean. That means subtract the mean from each value and ignore the minus signs because distance has to be positive. Step 3. Find the mean of those distances. Let's look at an example. Find the mean deviation of this set of numbers. You should record this example in your notes step by step. Press pause to stop the video and take notes, and press play when you're ready to start again. Step 1. Find the mean. To do this, you find the sum of the values in your data set. This is also called sigma, and the symbol for sigma is a funny shaped E. We need to find the sigma of all of the values and then divide the sum, or sigma, by the total number of values. In this example, the sum, or sigma, is 72. We take 72 and divide it by 8, and that gives us 9. The mean of this set of numbers is 9. Step 2. Find the distance of each value from that mean. For example, the first value in this set of data is 3. 3 is 6 away from the mean of 9. The second value is 6. 6 is 3 away from 9. If we were to draw out the values in this data set on a number line and indicate the mean, we can see the distance between each value and the mean. This is a useful diagram to copy into your notes. Next, we find the mean of those distances. That means we add up all of the distances that we found in the last step and then find the average distance. In this case, 3.75. So the mean deviation of this set of data is 375. Now let's talk about absolute deviation. Each distance we calculated is called absolute deviation because it is the absolute value of the deviation, how far it is from the mean. Remember, absolute value means distance. It is always written as a positive value. So, what does this all mean? Mean deviation tells us how far on averages all values are from the middle. You can use this information to compare 2 sets of similar or related data. For example, you and your friends have just measured the heights of your dogs in millimeters. The heights are listed here. You want to compare your dogs to the dogs in another neighborhood. The heights of those other dogs are also listed here. Let's find the absolute deviation. Let's look at your dogs first. First, find the mean. The mean height for your dogs is 394 millimeters. You should record these examples in your notes step by step. Pause the video to take notes and then press play when you're ready. Step 2. Find the absolute deviation for each value in your data set. A table is a useful tool to help you organize your data. Pause the video and copy this step and the table into your notes. Notice the bottom row of this table. In the bottom row of this table, we have calculated the sigma, or sum, of all of the absolute deviations for the data in this table. We need this information for the next step. Once we have found the mean and the absolute deviation, we are ready to find the mean deviation. We do this by taking the sigma, or sum, which is 636 in this example, and dividing it by the total number of values, which is 5. In this example, the mean deviation is 127.2. So, on average, the dog's heights are 127.2 millimeters from the mean. Remember, that can mean 127.2 millimeters higher than the mean, or 127.2 millimeters lower than the mean, because this is an absolute value application. Now let's look at your neighbor's dogs. First, we find the mean height. We do this by adding up all the heights and then dividing by the total number of heights, which is 5. The mean height of your neighbor's dogs is 425. Next, we find the absolute deviations. Again, a table is a really useful tool to help organize the data. Note that in this table, I have also calculated the sigma, since I know we will need this in our next step. Now we are ready to find the mean deviation. In your neighbor's dogs, the sum was 550. We divided that by 5, and we got 110. So on average, the dog's heights are 110 millimeters from the mean. Your dogs versus your neighbor's dogs. What does this really mean? Obviously, your dogs are way cooler than your neighbor's dogs, but that is not what we're trying to find out. We can put this information into a table, like the one shown, to help us analyze the data. We can look at this data and tell that the variation in height is greater for your dogs than in your neighbor's dogs.